The dawn of unified AI introducing Model Context Protocol, or MCP. The world of artificial intelligence is rapidly expanding. New models and tools emerge constantly. This vibrant growth, however, brings a challenge. How do these diverse AI components talk to each other effectively? Enter the Model Context Protocol, or MCP. It is an open standard designed with a clear purpose. MCP aims to create a universal language for AI. This allows AI models to seamlessly interact with external tools and services. Think of it as a sophisticated digital handshake. It enables different systems to understand and work with one another without complex, custom-built integrations. This protocol is not just a minor improvement. It represents a fundamental shift in how we will build and use AI-powered applications, making them more versatile and interconnected than ever before. In the context of Visual Studio Code, a popular development environment, MCP holds particular significance. It directly enhances the capabilities of GitHub Copilot's agent mode. This agent mode transforms Copilot from a simple code completion tool into a more active collaborator. With MCP, Copilot's agent can connect to any MCP-compatible server. This opens up a vast array of possibilities for developers. Imagine Copilot not just suggesting code, but also directly interacting with linters, build systems, or even specialized data analysis tools. This ability to tap into a wider ecosystem of functionalities makes the AI assistant far more powerful. It truly begins to feel like a knowledgeable partner in the development process, capable of understanding context and performing complex actions beyond simple text generation. The integration of MCP support within VS Code's agent mode is currently in a preview phase. This indicates that while the core functionality is robust, it is still an area of active development and refinement. As of VS Code Release 1.99, developers can begin to explore its potential. This forward-looking approach is exciting. It signals a future where AI in our development tools is not a closed box. Instead, it becomes an extensible platform. Developers and organizations will be able to customize and extend their AI's reach. They can connect it to proprietary internal systems or cutting-edge third-party services. This preview phase is an invitation to the community. It encourages experimentation and feedback, shaping the future of AI interaction within one of the world's most used code editors. At its heart, MCP addresses a critical bottleneck that has historically plagued AI development. Previously, integrating an AI model with a new tool often required bespoke, time-consuming engineering effort. Each connection was a unique project. MCP elegantly sidesteps this issue by establishing a standardized communication pathway. This standardization is key. It eliminates the need for countless custom integrations. AI models can discover and utilize tools through a common interface. Tool providers, in turn, can make their services available to a broader range of AI models without rebuilding their connection logic each time. This streamlined interaction promises to accelerate innovation. It allows developers to focus on creating value, rather than wrestling with interoperability challenges in an increasingly complex AI landscape. Deconstructing MCP, architecture, and collaborative power. The Model Context Protocol operates on a clear client-server architecture. On one side, we have MCP clients. Visual Studio Code itself is a prime example of an MCP client when using GitHub Copilot's agent mode. These clients are the entities that initiate communication. Their primary role is to connect to MCP servers. Once connected, they can request actions or information relevant to the AI model's current task. For instance, Copilot might ask an MCP server to analyze a piece of code, fetch documentation, or execute a test script. The client is essentially the AI's ambassador to the world of external tools, translating the AI's needs into requests that MCP servers can understand and process efficiently and effectively. This interaction is crucial for extending the AI's capabilities beyond its core training. On the other side of this architectural equation are the MCP servers. These servers are the providers of capabilities. They expose various tools and functionalities through a well-defined interface as dictated by the MCP standard. An MCP server might wrap a command line tool, an API for a web service, or even a complex data processing pipeline. These servers can be deployed in various ways. They might run locally on the developer's machine, providing quick access to local resources. Alternatively, they can operate remotely, offering access to powerful cloud-based services or shared organizational tools. The flexibility in deployment is a significant advantage. It allows for a wide range of tools to be integrated into the AI's workflow, regardless of where those tools physically or logically reside. The Model Context Protocol itself is the glue that binds clients and servers. It meticulously defines the message format used for all communication between them. This includes several key interaction patterns. Firstly, there's tool discovery. This allows the client and thus the AI model to learn what tools a server offers and what those tools can do. Secondly, there's tool invocation. This is the process by which the client requests the server to execute a specific tool with given parameters. Finally, the protocol handles response management, ensuring that the results from the tool are correctly passed back to the client. This standardized set of rules for interaction ensures that any MCP-compliant client can talk to any MCP-compliant server, fostering a truly open ecosystem. The benefits of this standardized architecture are manifold. The most immediate advantage is the drastic reduction in integration complexity. No longer does each AI model need a custom adapter for every tool it wishes to use. Furthermore, MCP allows for dynamic updates. Servers can announce changes to their available tools, or even add new tools on the fly, and clients like VS Code can adapt accordingly. This dynamic nature is crucial in a fast-moving field. Another subtle but powerful benefit is how VS Code, as an MCP client, can provide context to servers. For example, it can inform servers about the current workspace folders using a concept called. This allows tools to operate with a better understanding of the developer's project structure, leading to more relevant and accurate results from the AI. Activating Intelligence MCP setup and configuration in VS Code. Before diving into the world of enhanced AI with MCP in Visual Studio Code, a few prerequisites must be met. Firstly, developers need to ensure they are running a recent version of Visual Studio Code, specifically release 1.99 or newer, as this is when MCP support was introduced. Secondly, access to GitHub Copilot is essential, as MCP primarily extends the capabilities of Copilot's agent mode. Once these are in place, enabling MCP support itself is straightforward. The relevant setting is actually enabled by default in modern VS Code versions. This means for many users, the groundwork for MCP is already laid, simplifying the adoption process and encouraging exploration of its powerful features from the get-go. Adding MCP servers to your VS Code environment can be done in two main ways, offering flexibility for individual needs and team collaboration. For project-specific configurations that you might want to share with your team, you can define servers in a file within your workspace. This approach is excellent for tools relevant to a particular project, ensuring everyone working on it has access to the same AI enhancements. When using this method, it is crucial to exercise caution with sensitive information like API keys. Instead of hard-coding them, VS Code encourages the use of input variables or environment files, prompting the user for such details securely. Always ensure you are adding servers only from trusted sources to maintain security. Alternatively, for MCP servers that you want to use across all your projects, you can specify them in your user settings. This is done by configuring the setting within your file. This method is ideal for general-purpose tools or personal utilities that you find useful in various development contexts. VS Code also offers an automatic discovery feature, governed by the setting. When active, this allows VS Code to find MCP servers that might be defined or advertised by other tools installed on your system, such as the Claude desktop application, further simplifying the process of expanding your AI's toolkit. This multifaceted approach to server configuration ensures a high degree of adaptability for diverse workflows. Configuring an MCP server involves specifying its connection details and any necessary parameters. For example, connecting to a local server using standard input-output might involve defining the command to start the server and any arguments it requires. The example provided in the VS Code documentation for a Perplexity MCP server showcases this well. It uses to run a server package and defines an input variable to securely prompt the user for their API key. This array in the configuration allows for custom placeholders, which VS Code will handle by prompting the user on the first server start and storing the values securely. Server names should follow conventions like camel case for clarity and uniqueness, ensuring they are easily identifiable within the VS Code interface. Orchestrating your AI, managing and refining MCP servers. Once your MCP servers are configured, interacting with the tools they provide through GitHub Copilot's agent mode is quite intuitive. You begin by opening the chat view in VS Code, which can typically be accessed with a keyboard shortcut like Ctrl plus Alt plus Y on Windows or Linux, or Ctrl plus CMD plus I on macOS. Within the chat view, you then select Agent Mode. Here you'll find a Tools button. Clicking this button reveals a list of all available tools from your configured MCP servers. You can easily toggle these tools on or off, controlling which ones Copilot can utilize. Furthermore, you can directly reference a specific tool in your prompts by typing the symbol followed by the tool's name, giving you granular control over the AI's actions. Visual Studio Code provides robust mechanisms for managing your connected MCP servers. The primary interface for this is the command, accessible through the command palette. Executing this command opens a view where you can see all configured servers, whether they are defined in workspace or user settings. From this list, you can perform several actions: start, stop, or restart individual servers, view their detailed configuration, and, crucially, access their logs. This centralized management hub is invaluable, especially when dealing with multiple servers, or when a server isn't behaving as expected. Additionally, if you have a file open in the editor, VS Code provides convenient editor commands to manage the servers defined within that specific file. Troubleshooting is an inevitable part of working with any new technology, and MCP servers are no exception. VS Code aims to make this process as smooth as possible. If an MCP server encounters an error, or if Copilot fails to communicate with it, error indicators will typically appear directly in the chat view. These notifications often provide an option to show output, which will take you directly to the relevant server logs. These logs are your first port of call for diagnosing issues, as they contain messages and error details from the server itself. Alternatively, you can always use the command, select the problematic server, and then choose Show Output to view its logs. For common issues like those involving Docker containers, checking command arguments and ensuring the container isn't in detached mode are good starting points. The MCP ecosystem is still relatively new, but growing. If you're looking for pre-built MCP servers, the official MCP server repository on GitHub, maintained by SourceGraph, is an excellent starting point. It contains reference implementations, official servers, and community-contributed options. For those inclined to build their own, MCP servers can be written in any programming language capable of handling standard input-output. To further simplify development, official SDKs are available for popular languages like TypeScript, Python, Java, Kotlin, and C#. As more developers and organizations adopt MCP, we can expect a flourishing ecosystem of tools and servers, significantly expanding the capabilities of AI assistants like GitHub Copilot within VS Code, making our development workflows smarter and more powerful.